Hi everyone, I'm Quinn. I'm a junior studying chemical and biomolecular engineering with a little bit of computer science as well, and I'm originally from Havertown, Pennsylvania.
What's up, everyone? My name is Kofi. I am a sophomore studying chemical and biomedical engineering at Penn, and I am originally from and still am at the moment in Jamaica.
Hi everyone, my name is Jake Reisner. I'm a rising sophomore studying chemical and biomolecular engineering. Outside of Access, I'm involved in the Chemical Engineering Society, and this semester I'm at home in Chicago.
And last but not least, my name is Jocelyn, and I'm a sophomore studying chemical and biomolecular engineering. I'm currently studying at home in New York City, and we are all your CBE Access teachers for this semester.
This is the introductory video for chemical engineering, and right off the bat, you might be asking yourself, what is chemical engineering? As a student of chemical engineering myself, that's a really hard question to answer just because the field is so broad. Strictly speaking, it's the application of physical and chemical principles towards solving some kind of useful problem, whether it be the chemical engineers that produce everyday products from toothpaste to life-saving products like vaccines, or chemical engineers might work on electric vehicles to try to make them more efficient. As a result, our background needs to be really broad, and that's why we learn things like fluid mechanics to thermodynamics to organic chemistry and reactor design. But this really broad education gives us the foundation to solve really important problems that pertain to the environment, energy usage, and human health.
Our first video is about process engineering, which involves the design, control, and optimization of industrial processes. Process engineers transform raw materials into useful products at an industrial scale. We're going to focus on an important concept called material flow. Material flow is useful in understanding how systems with inputs and outputs change over time. Material balances are especially relevant to oil and gas. Engineers working at oil refineries design the chemical process for separating crude oil and extracting its components.
One of the fields where chemical engineers do their most important work is in environmental sustainability. Chemical engineers can work on anything from developing the chemical mechanisms of carbon capture technology to developing novel materials that improve our current effectiveness in water purification. Most commonly, chemical engineers can work in manufacturing divisions to ensure that heavily used processes produce as little waste and pollution as possible. As a result, one of our labs in Access this semester will be building a solar cell at home with materials that you can find around the house. In the process, we'll talk about catalysis and other technologies that chemical engineers use to combat climate change.
Chemical engineers are also very prevalent in fields such as biomedicine, pharmaceuticals, and biotechnology. Chemical engineers partake in numerous activities in all fields depending on the level of specialization you may choose to do. So this ranges from managing the drug production facilities in streamlining and optimizing the process to lower the cost of research and development of those drugs to the direct discovery and development of those drugs, working on the development of the drugs themselves. Over the past half century, chemical engineers have made rich and varied contributions to many biomedical advancements in an effort to modernize disease diagnosis and treatment options, improve the safety and efficacy of drug delivery mechanisms, and achieve better therapeutic outcomes. Here at Access, we'll be giving you a taste of some of the foundational work in biotechnology and pharmacokinetics in looking at basic enzyme action and mass binding. Okay, that kind of sounds a bit boring, but listen, trust me. Learning something like this allows you to understand quite a bit of things in pharmacology, like knowing the safe dose of ibuprofen to prescribe, or how much DNA you can clone given a specific amount. It's actually really cool, and we're excited to have you along for it.
And besides all of that, chemical engineers are involved in so many other things, from the formulation of paint to the creation of makeup, and even the refining and distillation of wine and beer. I mean, how cool would it be to work on a paint sample that ends up on your walls, or to drink something that you refined? Little do you know, there's chemistry in everything, which means chemical engineers play a role in pretty much everything. This could be your household detergent and cleaners, or your perfume and deodorant that you use every single day. The opportunities for chemical engineers are endless. But most importantly, chemical engineering teaches you how to problem solve and analyze complex situations. We hope that through this semester, you learn a little bit about chemistry, the applications of chemical engineering, and have a whole lot of fun as well.